Okay, so yes, we still have the limit as x goes to 0 of like x plus 3 o squared minus 9 o over x. So anyway, now we are doing the function. So we are sketching f of x. We say that it is equal to x plus 3 o squared minus 9 o over x, right? So we're going to do exactly what we did in that last thing to simplify it. But when we simplify, we are going to check what is it that we cancel. So first we expand, and when we expanded, we got x squared plus 6x plus 9. Then we had minus 9, and it was o over x, and we simplified it to be x squared plus 6x over x, right? Okay, now when I have it like this, okay, x squared plus 6x over x. Now when I have it like this expanded version, that is where I can look for end behavior, which is either the slant asymptote or the horizontal asymptote. And just by seeing that the power above is bigger than the one below, I know that this is going to be a slant asymptote because it's bigger than by 1. And how do I get it? Well, you can do the factorization. So it would be x, and here we remain with x plus 6, and it's all over x. Now what happens is this x and this x will cancel and remain with x plus 6, right? We remain with our f of x being equal to x plus 6, which is what we have done before, but we are doing it here. Now what we can see, we can already see that there is going to be a hole at this one which has cancelled, this x which has cancelled, yes. And now we can first say therefore, there is a slant asymptote. Slant asymptote, yes, slant asymptote, remember, it just means, it's true because we're going to have a slanted line. So the slanted line, you see, for slant asymptote, if let's say I had a curve, a slant asymptote is a slanted line which you can't cross. So if I had a curve, it would come like maybe like this and then like that, making sure it doesn't cross this line. So my curves could come like that. So here, because we already have a line, okay, so this line is lying on top of our slant asymptote. So that is what is going to happen. Therefore, there is a slant asymptote at the line. We say at the line, y equal to x plus 6, okay? Which is going to be, the slant asymptote is always y equal to something, and it is this answer which you remain with after you divide. And since here we could cancel out the common factors, we saw it in part A that we could cancel out the common factors. So we don't have to do long division. If we can't cancel the common factors, then we do long division to find the slant asymptote. Either way, we have this as our slant asymptote. Then now we can say f of x was equal to what? F of x was equal to x plus 6, okay? Now you're going to say, the other one is let x be equal to, maybe before we write this, we can say, let x be equal to 0, because x is what cancelled. Okay, the thing which cancelled is the one you say, let it be equal to 0. And remember, when you cancel slightly with the pencil so that they can see what was written before the cancelling. Okay, so you say, let x be equal to 0. And that just means x is 0. Okay, and now we have f of x being equal to x plus 6, right? Was it x plus 6? Yes. So we can now say f of 0 will be equal to 0 plus 6, which is just going to be equal to 6. And you can now say, therefore, there is a hole at 0,6. There is a hole at 0,6. And this already proves our limit, but we are still going to just sketch. So now we can put again to say f of x is equal to x plus 6, and you can say for y-intercept, we can have the intercepts, okay? For y-intercept, you say let x be equal to 0. Remember, for y-intercept, we let x be 0. Why? Because for y-intercept, we want to find where it cuts the y-axis, and that is the line x equal to 0. The y-axis is also called the line x equal to 0. So we let x equal to 0 at the y-intercept. So we can say f of 0 is going to be 0 plus 6, which is just going to be 6. So we can have it as the y-intercept. Okay, so the y-intercept. The y-intercept is at x0, y6. Okay? Then now we can have our gains to say f of x is equal to x plus 6. And we can say for x-intercept, we can now say for x-intercept, we say let y be 0. For the x-intercept, we say let y be 0. And our y is f of x. So we say let f of x be 0. So where there is f of x, we're putting 0. So 0 is equal to x plus 6. We take 6 to the other side. It becomes negative 6 is equal to x. So we can say, therefore, there is an x-intercept at What is the x value? -6. What is the y? 0, okay? Because we saw x is -6 and y is 0. There we have it. Now we can do our sketch. How easy is this? We have everything which we need. This is our y-axis, and here we have our x-axis. So now we can say, first of all, where is the x-intercept, which is the point where you cut the x-axis? It's at -6. So it's at -6. This is where you have it. Then what about the y-intercept? It's at 0,6. So it's at 6 in the y, which is going to be somewhere here. That is where you have it. Then what about the hole? There is a hole at also 0,6. Okay, there is the y-intercept. The y-intercept is at 0,6. You're going to say to me, how can you say you have a y-intercept at 0,6 and a hole? Okay, the truth is, you see at 0, look at the original function at part C. You can't put 0 in the denominator there. So we can't have this y-intercept at 0, that's where the hole is. So yes, there will be a hole at that 0,6. So actually what happens here is there will be a hole because we can't have x be 0. It will cause serious problems. It'll cause the denominator can never be 0. That function will become undefined. So that never works. So here we'll just take a ruler and join these 2 points. You just take a ruler and join these 2 points. Remember that when you get to the hole, you do this, then you continue on the other side. And this is going to be the function f of x is equal to x plus 3 o squared minus 9o over x, which is the function which you have. So you can say, therefore, since there is a hole at 0,6, okay, you can say in brackets y value of 6. You can now say limit as x approaches 0 of x plus 3 o squared minus 9 o over x will be equal to 6. It is equal to 6. And is it the same one which we got when we solved the limit numerically? Did we get the limit being 6? Yes, we got the limit being 6. So you can see that we are correct. Okay, something was happening at 6 and we saw that it was a hole at the y value of 6. Remember to put this y value, it's at 6. And you'll be having it. Now you are done. You have proved it and we say, well done. Okay, goodbye. See you in the next video.